Welcome to today's lesson. Today we will be beginning our study on trigonometric identities. But before we proceed to trig identities, let us first review the three basic trig ratios. We defined the three basic trigonometric ratios as sine, abbreviated SIN, cosine, abbreviated cos, and tangent, abbreviated tan, of an angle as follows. Consider the triangle, the right angled triangle. And in this right angled triangle is an angle which we've called theta. And opposite this angle, the side opposite the angle, we call it opposite. And the side adjacent to the angle, we call it adjacent. And the side, which is the longest side of the right angle triangle, we call it the hypotenuse. Therefore, the trig ratios are as follows. The sine of angle theta is the opposite over the hypotenuse. And the cosine of angle theta is equal to adjacent over hypotenuse, and the tangent of angle theta is equal to opposite over the adjacent side. These three ratios form the basis of all trigonometry. And to remember the three ratios, recall we use this SOHCAHTOA, SOH standing for sine being equal to opposite over hypotenuse, CAH standing for cosine of an angle being equal to adjacent over the hypotenuse, and TOA standing for tan being equal to opposite over the adjacent. Okay, so these are three trig ratios which form the basis of trigonometry, and we just cannot progress in this study without mastering these three trig ratios. The first trigonometric identity that we're going to learn is that the tangent of theta is identical to the sine of theta divided by the cosine of theta. Notice the way I write the symbol for identical, three equal signs. Okay, so stands for identical. So the tangent of theta is identical to the sine of theta divided by the cosine of theta. And where does this come from? So let us consider the right angled triangle, this one. So from the right angled triangle, we can show that the sine of theta, which is the opposite over the hypotenuse, is simply y divided by r, opposite over hypotenuse. And the cosine of theta, angle theta here, is simply adjacent over hypotenuse, so we've got x over r. And the tangent of theta is the opposite over the adjacent, so we've got y divided by x. Now, if we divide the sine of theta divided by the cosine of theta, we're going to get y divided by r, y over r, and further divided by x over r. This is cosine, and that is sine. Okay, x over r is cosine, and y over r is sine. So this is what we have here. And applying simple arithmetic, we will write y over r, which is this one, and then reciprocate this and change the sign to multiplication. So r will go on top and x will go on the bottom. And if the arrows cancel out, we'll remain with y over x. Now we've said that y over x is exactly equal to what? The tangent of theta. That's why y over x is. So we're saying, we decided from here, we're saying that sine over theta therefore is identical to y over x, which is simply what? Tan of theta. This is how we derive our first identity. Tan theta is identical to sine theta over cosine theta. Very important as we develop this topic, trigonometric identities. You've got to remember this for the rest of your life. The other trig identities which are very important in this study of trigonometric identities are called reciprocal trigonometric ratios. Consider the right angled triangle. In this right angled triangle, we see that the sine of the angle theta is equal to the opposite over the hypotenuse, which is y over r. And if we reciprocate sine, which means we write it as 1 over sine theta, we are also going to reciprocate y over r, which means the r will go up and the y will be the denominator. Now this reciprocal is called the cosec of angle theta, and it is identical to 1 over sine theta. This is the first reciprocal trig identity that is so important to us in this study. The next one is when we reciprocate cosine of theta, which is equal to x over r, adjacent over hypotenuse. If we reciprocate it, we write it as 1 over cosine. We are also going to reciprocate the right hand side, so we have r over x, and this reciprocal is called sec. So the sec of theta is identical to the reciprocal of cosine, which is 1 over cos theta. And the last reciprocal trigonometric ratio which we're interested in this study is tangent of theta being equal to y over x. If we reciprocate it, we have 1 over tan theta, which is y over x, and we call it cot. The reciprocal of tan is the cot of theta, which is identical to 1 over tan theta. Summary of trigonometric identities. So our first one is tan theta, which is identical to sine over cosine theta. The next one is the cosec of theta, which is identical to 1 over sine theta. And then we have the sec of theta, which is identical to 1 over cos theta. and lastly the cot of theta, which is identical to 1 over tan theta. Okay, so these four reciprocal identities are very, very important to our development of trig identities, and you've got to remember them off by heart. Thank you.